The first thing we see is they start talking about compound sentences, and it starts to feel like you are in English class. So compound sentences are really the same in math. You have a word that actually joins two thoughts, all right? And or are the two that we're going to look at with inequalities, all right? And so with inequalities, when you start combining them, the first way that you can combine them is with something called a conjunction. A conjunction is a compound sentence consisting of mathematical statements that are connected by the word and specifically. It matters because when you connect it with and, it means that the answer needs to work for both pieces. All right, if I were to say I am going to the grocery store and to the post office, you would assume that I did both of those, all right? If I said I'm going to the grocery store or the post office, then it could be either one, all right? And so that's how it's going to work here. When we're looking at conjunctions that are joined by the word and, we are looking at where they cross. So it says the intersection of the two inequalities is going to be your answer. Conjunctions can often, not always, but often be written all together. And so we're going to look at different ways that you would be able to see it. Sometimes they'll have two of these with the word and in between it. Sometimes they will just have them merged together where you have two different less than or equal to, or less than or greater than signs. And then you also have this symbol that looks like an upside down V. That is conjunction. And if you start looking at set theory, which you're going to do in geometry, your intersection will actually look like this. So they both look like an upside down letter. All right, so if you see either the notation, the V that's upside down, if it is all joined together, or if it is joined with the word and, you are talking about a conjunction, and you want to know specifically where do these two cross. Both of them have to be true for this to work, and so we're looking for where they cross. So let's look at just a general one. Graph the solution of x is greater than -1 and x is less than or equal to 4. And so when you are doing these, when you get to an answer like this, you are going to graph them. Now I usually will graph above it and then I'll decide where my answer is going to be. So for this one, x is greater than -1. Well, I would start at -1. Would I have an open circle or a closed circle? Open. It is just greater than. And greater than -1 would be everything to the right. And so that would be the graph of this one. And then I'm going to look at the graph of this, less than or equal to +4. I'm going to start at +4 with a closed circle. Less than or equal to is going to go this direction all the way down the graph. Now my answer of this conjunction with the word and is only where they cross, which means I am going to have an open circle at -1, a closed circle at +4, and my graph would be everything in between it. And this would actually be my answer, where they cross. So for conjunctions, and where they cross is the answer. All right. And so now we're going to actually do some solving to see where they cross. It says, graph the solution. This is just a notation difference. This and this mean the same thing. All right. They want me to graph the solution to this one, and they have written it with notation. This notation means and so I'm going to do exactly the same thing. I want it to be greater than or equal to +5 and less than 0. So I'm going to say closed circle at +5 and everything larger. And then open circle at 0 and everything smaller. Where do they cross? They don't, all right? And so if you get one of these and they do not cross, then your solution is going to be the empty set. You have no solution for something like this because there is no number that is greater than or equal to 5 and less than 0. And so with conjunctions, you can have an empty set. You can have a no answer. They'd never cross, so your answer is the empty set, meaning there is no number that fits it. So solve and graph the solution set of 2x plus 5 is less than or equal to 11 and -3x is greater than 18. So you are literally going to solve these individually. So I'm going to say I'm going to start here. And I'll say 2x plus 5 is less than or equal to 11. What am I going to do to solve it? What's my first step? Subtract my 5. So I have 2x is less than or equal to 6. My final step here is to divide by 2. X is less than or equal to 3. All right. Then I'm going to take the other one. Negative 3x is greater than 18. This is just one step here. Divide both sides by negative 3. X, what do I need to do here? I need to flip it because it's divided by a negative, and then 18 divided by negative 3 is 6. So my answer looks like this. X is less than or equal to 5. X is less than negative 6. So I only want where they cross over. If I graph this one, I have a closed circle on positive 3 and everything to the left. If I were to graph this one, I have an open circle on negative 6 and everything to the left. Well, where do they cross? They actually cross starting here and going this direction. That's where they cross. And so my answer would just be this right here. That is where they cross. They cross starting at negative 6 and going to the left. So for this one, there's actually two ways to solve this. If you just have an x in the middle, you can actually just do what you were going to do from all three pieces of it, or you can split it up. So I'm going to show you both ways. The first way for this guy is just to take it, and whatever you're going to do to solve for x, keeping x in the middle, you are just going to do to all three sides. So by that I mean I need to subtract the 5 to get it away from the x. Well, I need to subtract it from all three sections. So I subtract 5 here, and I subtract 5 here. So I subtracted all three places. It cancels in the middle, which is what I want. Negative 1 minus 5 is negative 6. I still have less than. Here I have just 3x. And here I have 8 minus 5, which is 3. To get x by itself, I would then divide by 3. Well, if I divide the middle, I need to divide every piece by 3. And so negative 6 divided by 3 is negative 2, which is less than, I now have my x by itself, which is less than 3 divided by 3, which is 1. All right, that is one way to solve it. The other way is just to break it up into two different inequalities, grabbing the left and the middle, and then grabbing the middle and the right. All right, and so I can just solve these individually if I want, and it will work out the same. So for this one, I would subtract my 5. I get negative 6 is less than 3x. Divide by 3. I get negative 2 is less than x. Do the same thing over here. Subtract 5. 3x is less than 3. Divide by 3. X is less than 1. And you're going to see that negative 2 is less than x, which is less than 1. What you'll notice is this looks like what your graph is going to look like. You're going to have negative 2 at one end point, open circle, because it is just a less than sign there. You are going to have positive 1 at the other end, open circle, because it is just less than. And then x is everything that is in between them. All right. And so when it's pushed together like that, you can solve it either breaking it up or you can solve it all together, whichever one is easiest for you to do. All right, that's really when you have just an x on the inside. If you have like the next example where you have x's on both sides, you're going to want to split them up into two different ones. If I have something like this, I'm really going to want to split it up because this guy kind of throws it off. And so if I have something like this where I have an x multiple places, you typically will want to do this. You'll want to split it up in the left and middle, split it up to the middle and the right, and then you want to solve two different ones here. And so if I solve this first one, I'm going to get all my x's to one side, all my numbers to the other. It will cancel here. Negative 1x, which means I need to move my numbers over. This is a negative 6. And I am going to keep my sign for right now, less than or equal to. I do need to divide here by a negative, so I'm going to say divide by negative 1. X, I do have to flip this sign, is greater than or equal to 6. All right? Then I'm going to solve the other one. All right? We're going to solve it exactly how we would. Plus 9. 2x is less than 24, and then divide by 2. X is less than 12, all right? So for this one, x is going to be larger than 6 and less than 12, which means I could rewrite it. This means 6 is less than or equal to x, which is less than 12. So my endpoints are going to be 6 and 12. Open or close circle at positive 6. Open or closed? Closed. And it went off my graph, so I'm going to have to give it a little bit extra. All right, so it goes all the way to 12. Open or closed circle on 12. Open circle on 12, and then I can graph everything in between. All right, it says if Brittany received a 73 and an 85 on her first two tests, what grades can she get on her final test and get a B in the class? All right, and get a B in the class. So a B is anything from 80 up to a 90. So she wants her grade to be somewhere in between these two. So if I were going to write it, I would say an 80 is fine, right? Because that is a B. And she wants it up to a 90. All right, somewhere in between there, she wants her grade. All right. How do we average them? Well, we are going to add up her test. We know her tests are a 73, an 85, and some grade on a test that we don't know. What are we going to put if we don't know the grade? An X, all right? How would we average those? We'd add them up and we would divide by 3, all right? And so we actually have something we can solve here. Okay, we're trying to get the x by itself. You can think of this like that, right? So my first step is actually to get rid of the 3. What am I doing with the 3? Multiplying or dividing? I'm dividing. So yeah, I'm going to multiply. And I'm going to multiply all 3 sides. Okay? So 3 times 80 gives me less than or equal to this. Less than or equal, not or equal to actually, 270. All right? What else do I do? Well, I need to get rid of this. You can do it a couple ways. I would probably add them first. What is 73 and 85? So I am going to subtract 158 from all 3 of these, right? On this side, 240 minus 158 gives me 82. Less than or equal to that test grade that I don't know. And less than, this is not hard, 270 minus 158 is 112. Unless there's a really big bonus, she probably will get less than 112. But what's the minimum she can make on a test? What's the minimum she can make on a test and still going to be an 82? It has to be greater than or equal to an 82, her test grade, in order for her to get a B in the class, right? So conjunctions have the word and. Disjunctions have the word or. A couple of things about this. The notation for a disjunction looks like taking the conjunction and flipping it. So it looks like that, looks like a V. But these will never be pushed together into one like the conjunctions are. So you'll never have something is less than something in the middle, which is less than another one. That will always be and. When it's pushed together as one, it will be and. Disjunctions will always be written separately. It will always either have the word or it will have your notation for the word or, which is the V, okay? Now for a disjunction, you're not looking for where they cross over. You're looking for all of the numbers that fit either of them, all right? And so it does not matter if they go in separate directions. Your whole graph will be the separate directions. Now, if they do cross over, then you're going to have a set of numbers that happens there. But it doesn't matter if they cross. You'll still have an answer for these. So let's do the first one. It just wants us to graph the solution. X is less than -4 or X is greater than -1. So we're going to start here. Open or close circle on -4. Open and everything smaller. And then for this one, open or close circle on -1. Open and everything larger. This entire graph is my answer. So whether it fits here or whether it fits here, it is true for this statement. Because if I say -8, -8 is either less than -4 or greater than -1. Well, that's true. It is less than -4. Or if I were to pick +4, +4 is either less than -4 or greater than -1. Yes, that's also true. Okay, so when you have the or, it can fit either of these answers and it's still true. If I said and, then it would be the exact opposite graph. It would have to be where they cross in order for them to both be true. And so if this were an and, I would say no solution. There is no number that meets both of these, -4 and larger than -1. Okay, but the or says it can be any of them. All right, so it does not have to cross in order for it to be a solution. All right, let's look at what happens when we throw in something like this. This is my notation. All right, so you are always going to have the word or in between, or you're going to have the notation in between. Same thing here. So we're going to look at these. X is less than 4. Open circle on +4. And everything to the left. All right, that's this one. Or X is less than or equal to +2. And everything to the left. Now, for this one, it is an or. So instead of starting here, like I would if it were where they cross and say it's everything here, it can actually be everything from here this way because it's or. And so my graph is actually going to look like this. You're basically looking for the most open of the two. Whichever one includes the most numbers is going to be your answer when they cross over for an or. Whereas for an and, you're actually looking for the one that has usually the least because it's where they cross, okay? Because this would fit both of those scenarios, all right? This would fit both of those scenarios. And so when it's an or, you're graphing both of them, and if they cross over, it just keeps going. You don't have to worry about only where they cross.